This Zoom session is being brought to you by the Fractal Squared Circle. All right, for today, we're going to do graphs of tangent, cosecant, secant, cosecant, tangent, and cotangent. Now, the secant is the reciprocal of the cosine, and the cosecant is the reciprocal of the sine. So whenever cosine is 0, which is at integer and a half times pi, then secant is infinity. Whenever cosine is plus or minus 1, at integer times pi, secant is plus or minus 1. So here's a graph of it. I suppose it'd be easy if I draw the cosine in here as well, which goes like this, 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 this. And every time the cosine is 0, the secant zips off to infinity. And here it's 1 at 0, and so it goes off to infinity and infinity, and it goes off from negative infinity to negative 1 to negative infinity, then positive infinity to 1 to positive infinity, and so on. Like cosine, it has a period of 2 pi. I like to think of it as basically it's like a cosine, only instead of oscillating through 0, it oscillates through infinity. Cosecant is 1 over sine. And so whenever sine is 0, which is at integer times pi, cosecant is infinity. Whenever sine is plus or minus 1 at n½ times pi, cosecant is plus or minus 1. And again, period 2 pi. And since cosine and sine are quarter phase off of each other, pi over 2 phase off of each, 90 degrees off from each other phase, so are secant and cosecant. Tangent and cotangent, well, tangent is sine over cosine, so it equals 0 whenever sine is 0 at integer times pi, and it equals infinity whenever cosine is 0 at n½ times pi. So you can draw 0, a 0 here, a 0 here, a 0 here, a 0 here, and in between the zeros are infinities. And okay, it's not immediately obvious from here, but tangent is always rising, or it's always slope positive. So negative infinity to 0 to infinity, negative infinity to 0 to infinity, negative infinity to 0 to infinity, and so on and so on. Cotangent, and it has period pi. Cotangent is cosine over sine. So it's infinity at whenever sine is 0 at integer times pi, and it's 0 when cosine is 0 at integer and a half times pi. And it's always falling. That's not immediately obvious, but it is. And like tangent, it has period pi. So compared to tangent, it's both phase shifted and flipped upside down. So it's falling from infinity through 0 to negative infinity, positive infinity through 0 to negative infinity, and on and on. I like to think of these as spiraling. Imagine wrapping the plane around so that plus infinity meets minus infinity. Then this is a spiral. It spirals around the number tube. I guess you might say it's clockwise, and this spirals in the opposite way around the number tube, counterclockwise. No. And just like, and if we're going to throw in a frequency, secant omega x and cosecant omega x, well, since these have period 2 pi over omega, tangent omega x and cotangent omega x have period pi over omega, just like respective, these just like sine and cosine. All right, so here are some examples. Let's graph y equals tangent pi halves x. The period is pi divided by pi halves, that's 2. Now, okay, the thing to do is draw a little table. At 0, y is tangent 0, which is 0. And every 2, it recurs to 0 to 0, and in between each 0, it reaches infinity, and it's always rising. So whoosh like this, whoosh like this. So you have 0 at 1, it's infinity. It's 2, it's 0. At 3, it's infinity. At 4, it's 0, and so on. So whoosh, 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 whoosh.
Question?
Yes.
Does it ever reach 1 and 3, or does it approach 1 and 3 as it goes to infinity?
Well, I mean, at 1 and 3, it equals infinity if you take infinity seriously. But
so I guess the question is it an asymptote, or
yeah.
It is? Okay.
It's an asymptote. Here's cotangent of a quarter x. Well, okay. Period is pi divided by 1/4, which is 4 pi. Now at 0, it's cotangent 0, which is infinity, plus and minus. So therefore, 4 pi units later, it's again to infinity. At 8 pi, it's back to infinity. And between the infinities, it's a 0, and it's constantly falling. Whoosh, 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 whoosh. Now this is hand drawn, but of course, a modern way to do this is to run to a calculator. He is graphing 2 secant x. Period is 2 pi, like cosine is. And it has a, you might call it an amplitude, but I was at least 2. So at 0, secant 0 is 1. So twice that is 2. And 2 pi units later, we're back to 2. And then at 4 pi, it's back to 2. In between the 2's is a -2 and -2. And between the 2's and -2's are the infinities. So, okay, here it's 2 at 0. It goes off to infinity at pi halves, then -infinity to -2 to -infinity, and so on, and so on, and so on. This one they're deliberately being annoying. Graph y equals secant of 3 pi over 2x, all that plus 2. This plus 2 means you're going to have to lift it 2 units. The period is 2 pi over 3 halves pi, which comes up. Ooh. Oh dear. Did I blow this? I think this is a mistake. I think I have to get honked. You have to divide by 3 halves pi, not 2/3 pi. And 2 divided by 3 halves. That's 3/4. This is wrong. Call me incorrect. I'll have to change this in the units. But I'm going to change this to 2/3 just to make it a little easier. And okay, if this were 2/3 instead of a 3 halves, then we'd have a period 3. So at 0, it'd be secant 0, which is 1 plus 2 makes a 3. And then 3 units later, I change this properly, get back to a 3. Halfway between, this would be a -1 plus a 2 makes a 1. So it goes between 3 to 1 to 3 to 1 to 3, and infinities between those. So 3 to 1 to 3 to 1 to 3, and dotted line and vertical asymptotes halfway between. Okay, this I'm going to have to change. Specifically this. Let me make a note. 2.5, page 6, secant 2/3 pi x. Okay, fine. That was anyhow. So okay, that's that for that.